we're picking up with Unit 2, Lesson 11 on graphing rational functions with example 2. We have a real-world problem here about average speed, and it says a boat traveled upstream at R1 miles per hour. During the return trip to its original starting point, the boat traveled at R2 miles per hour. The average speed for the entire trip R is given by the formula R equals 2R1 times R2 divided by R1 plus R2. Draw the graph if R2 equals 15 miles per hour. So the first thing we're going to do is we're going to plug in that number 15 that they gave us and then simplify this equation. So we have, once we do that, we get R equals 30 R1 divided by R1 plus 15. It might be helpful for you if you think of this as the big capital R as the letter Y and this little r1 as the letter X. And if you need to do that to make it easier for you, go ahead and do it. The variables don't really matter. So the first thing we're going to do with this problem is look for our vertical asymptote when the denominator equals 0. And since our denominator is r1 plus 15 or x plus 15, you can figure out the vertical asymptote is negative 15. The horizontal asymptote would happen, let's look at the powers. This is first degree, this is first degree. When they're the same degree, the horizontal asymptote is the coefficient of those leading degrees. So here we have a 30, here we have a 1x. So 30 divided by 1, the horizontal asymptote is going to be 30. So then after that, once you have your asymptotes, you're just going to pick some values of x. Let's come over here. I'm going to go over on my grapher and graph these points. So let me get rid of those things, put in my table. So I know that I have an asymptote at x equals negative 15. I have a horizontal asymptote when y equals 30. Let me zoom out a little bit so I can see this better. Okay, so negative 15, let's pick some values that are close to negative 15 so we can see where the function is on either side of it. So let me pick, let me go negative 20, negative 19, negative 18, negative 17, negative 16. Let me do negative 15.5 and negative 15.25, just so we can get a view of what's happening really close to this asymptote. And then we'll do negative 14.75, negative 14.5, negative 13, negative 12, negative 11, negative 10. I know that's a lot of values, but what I'm going to do real quick is just try to dump all those in my graphing calculator and see what values I get out. And remember that our equation is 30x divided by x plus 15. And I don't want to look at that graph yet. So let me move this up to the top expression so I can see it a little bit better. And I'm going to add another expression in here. Okay, so on first value I'm plugging in is negative 20. So I'm doing 30 times negative 20, negative 20, and that's divided by, let me put some parentheses around that, 30 times negative 20, whoa, wrong expression, do not want to be in there. Okay, in here, 30 times negative 20, close my parentheses, divided by negative 20 plus 15. Okay, it's 120. Then I'm going to change this to negative 19. Okay, 142.5. Negative 18. 180. Negative 17. 255. Negative 16. 480. Let's do 15.5 now. 930. 15.25. 1830. See, that number is obviously really big. It must be going off to positive infinity. Then we're going to do 14.75. 14.75. Negative 1770. So we must have been coming up from negative infinity. 14.5. Negative 870. 13. Negative 195. Negative 12. Negative 120. Negative 11. Negative 82.5. Negative 10. And negative 60. Okay, see our point's right now really far away from that line. I'm going to change my scale around a little bit. I don't need all this stuff out to the right, so I'm going to change my x-axis to go maybe negative 40 to 0. And for my y-axis, I'm going to go, I don't know, negative 2,000, positive, what was my, oh, I only need to go up to y equals 30. Wait, no. Let's go up to like positive 2,000. Okay, turn that off. Okay, so now you can kind of see a little bit better that this piece curves up, and this piece over here comes up, and it's going to approach that horizontal asymptote. So now if I fill in this expression, so we have the actual graph, when I connect all those dots, you can see it looks like that on the right side and on the left side. We get this nice smooth curve. Each one is not going to touch this vertical asymptote of negative 15, and they're not going to touch the horizontal asymptote of positive 30, which we had graphed over here. So let's come back over here to our problem. There's the graph that they have. Part B, what is the r-intercept of the graph? So remember r was what we called y, so we're looking for the y-intercept on our graph. Where do we touch the y-axis? That's way over here when x is 0, 0, 0. Notice here, 0, 0 is where we touch the r-intercept. The r-intercept is 0. What domain and range values are meaningful in the context of the problem? Remember, this is about rates, which are speeds that you travel at. So it says values of R1 greater than or equal to 0, and values of R, big R, the total rate, the average rate, between 0 and 30 are meaningful. Think about it. If we're talking about speeds that you're moving, can you move at negative speed? No, you can only move at positive speed or 0 speed. And the average rate that you can move at has to be between 0 and 30, because those were the limiting values from the asymptotes. The lowest value, that the average speed could be 0. You can't have negative average speed. And the asymptote, the horizontal asymptote, let me zoom in. You can see if this is 10, 20, 30, our horizontal asymptote of 30, you can't have a higher average rate than that because that's your horizontal asymptote. You can never go higher than that rate. Okay, here's a check your progress problem. Go ahead and pause the video and read through this. You're going to work it out the same way that we just worked out our current problem. I'm going to go into the next screen now so you can read part B. Okay. You're going to want to pick your answer to this, pause your video. When you have your answer, go on to the next screen. And after that, we're going to look at part B for this problem. So our answer now to part A, our graph is graph A. And now we're going to look at part B of the problem. What is the v-intercept? So go ahead and think about that, and I'll advance to the next slide now. So the v-intercept, the answer for that is A. It crosses the axis at the value of 30. And let's see if we have a part C. What values of t1 and v are meaningful in the context of the problem? Think about what values can t be, what values can v be. I'm going to advance to the next screen. Make sure you have your answer. Our answer for part C, B. T1 has to be positive, and V has to be between 30 and 60. All right, we're going to end this video now and pick up with example 3 in the next video.